Assalamualaikum warahmatullahi wabarakatuh and good morning to all. Okay, this video session is actually I want to explain about how to perform the full vehicle analysis using the motion view. Before this, for video before, you already learned about how to run the suspension analysis for static ride and also kinematic and compliance. So this video is purposely on how you want to run full vehicle analysis using the motion view. Okay, so for the first step, you need to open up your motion view using the HyperWork Desktop 2020. If you use the version of 2020, you need to open up for the HyperWork Desktop, and then you change it to the motion view. Okay, you change it to the motion view. Okay, so next you need to load the preference file for the vehicle dynamics. Okay, so this load preference files. You need to select the load preference file, and then you choose the NBD vehicle dynamics tool in order you to run and perform the vehicle dynamics modeling. Okay, so you need to click the loads, and then next you can uh, set up the full vehicle model, okay, for the vehicle dynamics, and then you click for the model here, and then you select the assembly wizard there, same like what you do for the suspension analysis. You set the assembly wizard, so it will appear this car small truck model type, and you have a front end vehicle, rear end vehicle, full vehicle with driver, test rig and powertrain model. Okay, in order you to perform the full vehicle analysis, so you need to choose the full vehicle with the driver. Okay, full vehicle with driver, and then you need to click next. Okay, and then you can select the driveline configuration. So you can choose either you want to perform the front wheel drive for your vehicle, rear wheel drive, and also four wheel drive. Okay, okay, I will choose the front wheel drive here. Okay, and then you click next, and then this is a primary system, the parameter for your full vehicle. Okay, so this is a vehicle body. Okay, same instrumentation you need. Let's it's by default, and then you can choose either you want to put the subframe or not for your front suspension. Okay, if you want to put the subframe, you can choose the front subframe. If you don't want to put the subframe, you just choose a none. Okay, and then you need to choose what type of front suspension that you need to choose. Okay, we have a several type, seems like what you do in the suspension analysis. We have a McPherson, one piece, two piece lower control arm, SLA, multi-link, and then you can choose. Okay, so I choose the McPherson one piece lower control arm. And then steering linkage, we have a rack pinion steering, parallel steering, double ideal steering, subframe, rear subframe. Okay, if you want to put rear subframe, you can choose rear subframe. And rear suspension type, okay, you have a quad link, solid axle, McPherson, SLA, semi-trailing arm, two-spin, trailing arm suspension. Okay, let's say I choose the multi-link with LCA. Okay, and you need to choose the powertrain. Okay, powertrain, we have a linear torque map powertrain and also IC engine. Okay, IC engine, so I choose the linear torque map powertrain. So tires is have just only the auto tires. Okay, after you complete the primary system, okay, you set up the front suspension and also rear suspension, you can click next, and then you can set the parameter for the steering subsystem. Okay, the steering column and the steering boost. If you don't have any selection here, you just click next, and then you need to set up the spring, dampers and the stabilizer bar. Okay, for the strut, you can choose the front strut, inline joints, front stabilizer bar. If you want to put the front stabilizer bar, you can choose the front step bar with link, or the other one is the front two-piece step bar with link. So rear shocks, you can choose rear shock, rear spring, and also rear stabilizer bar. Okay, for example like this. And then after you finish it, you can click next, and then you need to set the parameters of a jounce and rebound. If you don't want to put this parameter, you just put it as a none, and then you click next here. So this is a driveline system, so this brake and also independent forward, just let it by default. And then you click next here. This is a driver system and just on the alter driver, and then you click next and also finish. Okay, finish. Okay, so it will create your full vehicle model in the motion view. Okay, so this is a full vehicle model. Okay, it's a different what you do for the front suspension analysis. So this is a full configuration of the full vehicle, consists of front suspension, rear suspension, wheel, body, powertrain. Okay, so this is how you want, this is how the full vehicle look like. Okay, if you see, this is a front suspension system. We have a stabilizer bar, we have a McPherson suspension type here. Okay, and we have the green one is a powertrain. Okay, the powertrain here. This is the spring dampers, the wheels, the brakes. Okay, here, and at the center of the body is a CG. Okay, COG of the vehicle here. This is COG of the vehicle. Okay, and the next one is a rear suspension configuration. Okay, rear suspension configuration. I choose before this I choose the multi-link. Okay, multi-link with the LCA. So this is a configuration system of the multi-link. What you see, we have a multi-link suspension with the stabilizer bar. Okay, okay, so at the left side view here we have some model configuration. Okay, for this, like before, we have a bodies here with a ground bodies here. Okay, ground bodies, data sets, markers, point, vectors. Okay, and also miscellaneous. Okay, and the miscellaneous is a data sets. In the data set we have a standard report here, and also form. We have a gravity here. If you want to off the gravity, you can off here, and also the units. Okay, units. This is a by default units. Length in millimeter, time in seconds, mass kilogram, and force in Newton. So you can change. If you want to put the length in meter, you can change it here. Okay, and also this is a body. Okay, body, vehicle body. If you click on that, you can have properties of the vehicle body, so you can change the vehicle body. So vehicle body, like mass and also the initial properties. If you have your own measured data for the mass and also initial properties, you can insert it. Okay, you can insert it with the actual data. Okay, so we have a graphic we join here, and then next is the front McPherson suspension. Okay, they consist of the bodies, knuckle, lower control arm, wheel, and also wheel hub. We have a bushing data here. Okay, so all this you can change the parameter. If you click on that, you can change the parameter of the mass and also inertia for the bodies, and also for the bushing. If you have your own stiffness data, you can change the translational stiffness and also rotational stiffness data. Okay, for the bushing. And then we have the front strut here. Okay, front strut. We have a spring dampers. Okay, if you want to change the spring stiffness. Okay, so this is a linear stiffness. The by default is a 30 Newton over mm. Okay, 30 Newton over mm. So if you want to make it as a stiffer, you can increase the value of the stiffness, or you want to make a less stiffer, you can reduce the value of the stiffness. And same with the strut damper. Okay, the damper here, we have the C damper here, just only the value is 1. Okay, this is for the front strut and also spring. And we have the front stabilizer bar with the link. Okay, here as a body here, drop link. Okay, and then this all the parameter for the front McPherson. And then we have a rack pinion steering data. Okay, if you want to change the parameter for the rack pinion steering, you can change it here. And the next is the rear suspension. Okay, multi-link with LCA. So same with the front McPherson. Okay, you can change the parameters mass and also inertia for all the bodies for the rear multi-link. We have a consist of wheel hub, knuckle, LCA, front UCA, rear UCA, and also the tolling. And also we have a bushing here. Okay, LCA front bush and also rear bush. We have a rear shock absorber here. Okay, same. We have a shock damper there. If you click that, it will highlight it here. Okay, this is a shock damper. Okay, shock damper. And we have a rear coil spring. Okay, spring dampers here. Coil spring. If you want to change the stiffness of the spring, you can change the spring here. So damper, same with a damping rate. Okay, and also stabilizer bar. Okay, the stabilizer bar here, the rear stabilizer bar here. Okay, you can change the parameter. And also next, after the rear suspension, we have a linear torque map powertrain. Okay, linear torque map powertrain. If you click there, so this is a powertrain system. Okay, with the mounting. Okay, with the mounting. So we have a bodies of powertrain, including engine and also the transmission. Okay, the mass and also the inertia. We have a bushing for engine mount. We have a 3 mounting here, engine mount 1, 2, and also the 3. We have a curve data, which is the gear ratio. Okay, if you have your own the gear ratio spec for your powertrain, you can include it here. Okay, you can include here. And also we have a powertrain data, engine clutch, total scaling, maximum powertrain. So you have your own powertrain data, you can insert it in here. Okay, the force, differential torque. Okay, and also this is just by default. Okay, and then we have the auto tires here. Okay, the tire is a tire fronts. This is a front tire. Okay, we have a front tire here. The property file, you can change if you have your own tire properties, which is the radius, the width, aspect ratio, wheel mass. Okay, hub offset. For all this, you can change it as a tire data. Okay, same like a rear. Okay, so if you have your own properties of the tire, you can change it for properties based on the actual data. Okay, next we go to the brake system. Okay, this brake. So this brake here, we have a pedal ratio, master cylinder piston area, rear cylinder piston area, maximum pedal force. So if you don't have any data for the brake system, you just let it by default here. Okay, let it by default. And also we have an independent forward. Okay, independent forward is a drive line. Okay, or drive shaft here. So this is a drive shaft. And then at the bottom one is the alter driver. Okay, for the alter driver we have a parameter for the vehicle. Okay, vehicle parameter. So you can change the vehicle parameter here. We have a vehicle mass here. Okay, vehicle mass. Vehicle mass is a auto calculated based on the all the parts, start from the body until the independent forward. So the calculated load or weight for all the vehicle, full vehicle, is the 1.5 ton. Okay, and we have the front cornering stiffness. Okay, it's not same like spring stiffness. Is calculate for the front stiffness, cornering stiffness. So dia punya value kat sini adalah 51,000. Okay, cornering stiffness. Dia punya unit adalah Newton over radian. Okay, Newton over radian. And same with the rear cornering stiffness. Okay, so the function of the front cornering stiffness and also rear cornering stiffness, if you want to check your if you perform the full vehicle analysis, for example, single lane change, step steer, constant radius cornering, if you increase or decrease the value of front cornering stiffness, it will affect the lateral acceleration and also the cornering event for the vehicle. cornering behavior of the vehicle. So you can check if you increase the front cornering stiffness or reduce the the cornering stiffness, you can see the behavior will effect. Okay, it will give you different behavior for your full vehicle. Okay, so this is the alter driver. Okay, so you already upload the full vehicle model, and also if you want to change the parameter here, you can change it. Okay, if you satisfied with all these parameters, so now you can run it, uh, your full vehicle analysis. So how you want to perform the full vehicle analysis? So you go to the analysis here. Okay, you go to the analysis. Wait, you go to analysis. Okay, if you click on the analysis, it will choose you a task wizard. Okay, a task wizard, you click on the task wizard here, so it will appear add event. Okay, add event. So if you click on the type, which is the alter driver file, so it will appear the several type of the full vehicle event. Okay, the first one is the braking in turn, constant radius cornering, double lane change, J turn, power off straight line. Okay, pulse steer, we have a road course drive. Okay, we have a single lane change, we have a sinusoidal steering, we have a step steer, and also straight line acceleration, straight line braking, swept sign, swept steer, and also total off cornering, total off turn in, and also end post shaker. Okay, so we have a few type of full vehicle analysis. Okay, it's depend if you work in the vehicle dynamics, so you can try to run for several type for full vehicle analysis in order you to evaluate the vehicle dynamics performance for your vehicle. Okay, for example, I choose the double lane change here. Okay, double lane change, you click on that. Okay, you click on that, so you can change the variable name here. If you want to put your own name of your analysis, you can change it, and then if you don't want, you can let it by default here. Okay, and then you click OK. You click OK. After you click OK, it will appear the event editor here. At the bottom sides of the motion view here, it will appear the driver event. Okay, it will show the double lane change event. Okay, so it will explain what is a double lane change event. Vehicle travel along a straight at a constant speed in the first section, switch a lane in the second section, and the maintain straight in the line. In the next section, the lane is switched back followed by a straight line again. Okay, so this is how the overview of the double lane change. It will start for the straight line for the first section here, and then you go to the switch a lane for the second section, and then go back to the straight line for the third section, switch again the lane at the fourth section, and then maintain the straight at the fixed section. Okay, so this is a double lane change for the behavior for this event. Okay, you can change the parameter of the double lane change here. You just click on the event editor here. Okay, you click on the event editor, so you can change uh, uh, the parameter of the road profile. Okay, how you want to set when the length for the section 1, the length for the section 2 for the switching the lane, and the section 3 here. So the model means it will go back to the units that you set at the model. Okay, if you set the millimeter, so means that all these units in the millimeter. If you change to the meter, you need to change a meter. Okay, so by default you can change, you can set it by default here. Okay, and then you can change the event here. Let's say I want to change this. This is a solver input file. Okay, you can change the directory file here. So if you set the other folders or other input file there, the directory, you need to find that at your folder directory, so that all the result file will go to that folder directory. Okay, for example, I change to the baseline. Okay, baseline, and then you can run. You click on the run, it will run it for the double change event. Okay, you just click on the run, and then it will appear the message log and also the solver. Okay, so it will run it. So you just wait until it finish or complete the job. Okay, so when it show the motion soft job completed, so means that the event analysis is already complete run. Okay, so you can see the result. You just click on the result here, so it will open up the hyperview. Okay, it will open up the hyperview software, hyperview interface. Okay, so this is a load model and also result file. So based on the name that you are given, okay, and also the directory that you are set before. Okay, so this is an event on the double lane change. Okay, here, so this is a full vehicle. Right, if you see, so this is a event for double lane change. This is a first section, second section, third, fourth, and also the final section. So the vehicle will go straight line, go to the second section, change the lane, make it a straight, and then next change the lane back, and also go to the straight. So you can play the animation here. So you click on this animation, so it will show you the animation of the vehicle. It's quite slow. Okay, it's depend on the your punya PC performance. Okay, kalau berat mungkin berat sikit lah nak run. The slow is for the first time. Nanti dia akan repeat, nanti dia akan laju sikit lah dia punya animation. So dia akan habis for the first time animation is quite slow to run. Okay, so you see, this is how the double lane change vehicle analysis. Okay, so this is from the top view. Okay, from the top view. If you want to see from the front view, how the behavior of the front view, so this is how the behavior of the double lane change here. Okay, so if you see that it quite slow because I said the velocity of the vehicle is just only the low vehicle speed. You can increase the vehicle speed in order you to evaluate the performance of the vehicle. Okay. Okay, so this is animation for the double lane change. So you can see the plotted graph. Okay, what you want to see in the double lane change here. So I need to see side by side. You can change the select from list here. the page window layout. You can choose here side by side. Okay, for this side, for the right side, you can change to the hypergraph. Okay, you can change to the hypergraph, and then you need to upload the file. Okay, the file, you need to upload the ABF file. Okay, the ABF file, the name, and then for this you can put it, the X type is a time. Okay, and then you can go to the expression. Okay, expression here. In the expression, if you click on this, so it will show you the what is parameter that you want to see. Okay, the first one is a vehicle displacement. Okay, and then vehicle velocities, vehicle acceleration, side slip angle, front suspension travel, rear suspension travel, front side slip, rear side slip, pitch, front lift, rear squat, front axle load, rear axle load, rack displacement, steering angle and torque, engine torque, brake torque. Okay, driver input. So semua ni kita boleh tengok lah. So sama juga you boleh pergi kepada request subsystem. So kat sini pun ada banyak, ada macam-macam kat sini lah. Okay, if you choose the request subsystem, we have a front steer angle, rear steer angle, vehicle roll, tire left, until a driver request here. Okay, for this load case, I will choose the expression. Okay, I will choose the expression, and I choose the vehicle acceleration. I want to evaluate the lateral acceleration. Okay, the lateral acceleration. So how about when we do the double lane chain, how about the value of the lateral acceleration? So for the lateral acceleration, you need to choose the F3. Okay, F3, you click on the preview here. If you choose F1, you just don't have any value here. F2 is it's not lateral, it's a longitudinal acceleration for F2. And also this is F3 for the lateral acceleration. So this is the value for the lateral acceleration. The in G's, okay, G's degree per second squared. Okay, so how many G's for the lateral acceleration? So it's about 0.15 around G's. Okay, this is the behavior during the lane change. Okay, the behavior of the during lane change. So you need to evaluate there. And then you can change, you can check the side slip angle. Okay, side slip angle. You click on the F2 here. So this is a side slip angle. So angle, side slip angle. And then you can change the, you can check for the steering angle. Okay, this is the steering angle. You can choose the F2. Okay, F2. So this is a steering angle during the lane change. So you can evaluate this. Okay. So this is how you want to perform the double lane change. Okay. And for the lap session, you need to change the, let's say you want to change the parameter. Say you go back to this. Let's say I want to change the cornering stiffness. Okay. So the cornering stiffness for here is a 51,000. Okay, I want to make it as a stiffer cornering stiffness. Let's say I want to put this quite higher, which is a 80. Okay, 80 instead of 51. I put the 80, and then I can try to run back for the double lane chain, and then we see the different. What is the different? Okay, so I choose the double lane change here. Okay, and click for the event editor. I put a name, different name. Let's say I put the 80k. Okay, and then I try to run. So it will run. I change the parameter of the cornering stiffness, so will affect the. I want to see, is it, if I increase the stiffness of the cornering, is it will affect the vehicle lateral acceleration, side slip angle, or steering wheel angle, for example. Want to see the behavior of the vehicle. Is it, if you make it as a stiffer cornering stiffness, how about your performance of the your punya vehicle? So we will see that. Okay, so already complete the analysis for increase the stiffness. You can go back to the graph here. Okay, the graph here. So you just upload the graph for ATK. Okay, I name it as the ATK. You just upload the ABF file here. Okay, you just upload the ABF file. So you choose the same expression, vehicle attack, F3. Uh, okay, this is ATK. I go back to the baseline here. Okay, I choose the expression, vehicle attack, F3. Okay, so it show you a quite different. Okay, the blue one is the ATK. Okay, the blue one is the ATK, increase 80, and the red one at the bottom one is the baseline. Okay, so it show you quite different behavior for the lateral acceleration. Okay, so you can change the parameter of the cornering stiffness. Maybe you can try to decrease the behavior and also increase the stiffness. So you can see how about the change. The pattern is the same, but the value maybe will be lower from the baseline and also higher from the baseline. So you need to evaluate. You need to evaluate. What is the different what is a different performance when you increase the cornering stiffness and also you decrease the cornering stiffness. Okay, so that's all for this full vehicle analysis explanation. So hopefully you understand what you can do for the lab session for full vehicle analysis. Okay, so thank you very much. Assalamualaikum warahmatullahi wabarakatuh.